As well, we can show our results of the analysis by listing them. So while plotting the results provides better view of the component distribution, their listing provides a higher precision. So the program presents the lists in tables. The main weakness of the listed results is in their quantity, because sometimes it's very difficult for this data to be sorted and analyzed. So if we wanna list our stress displacement strain, we can right click here on the result, and here we have list stress displacement strain. And now here we can choose what we want to list, stress, displacement, or strain. Let's go with stress. Which component? We can choose here from this menu. Let's go with von Mises, and here we have advanced options. So we can go with nodes or elements center. By selecting nodes, the software is being informed to list the selected stress in the nodes, while selecting the element center lists the calculated stresses for the element modes. That means that each element value is an average value of the stress fixed to the element nodes. So let's go with nodes, and here we can choose what we want to list. Criterion, absolute maximum, here we have minimum. Or we can go with a range, from one value to another value. So let's go with extremes, and let's go with maximum stress. Let's click OK. And now here we have listed 3 maximum stresses. So we have a node here, ID, position, and the value. We can also save this if we want. Let's close this. Let's go again to our list. Let's go with stress. Let's go advanced options. And now let's go with minimum. And here we have list all values within 5%. And let's click OK. Let's go with this one to the left. And now we have the minimum values, 5% of the minimum values of the stress. Let's close. Let's go again to the list stress displacement strain. You can also go to displacement, advanced options. You can also go here with maximum minimum. You can put a range. So you have the all same thing. We can click OK. And now here we have a list of our displacement. 5% of the maximum displacement. Let's close. So this is how you can list stress, displacement, and strain. Now we're going to show how you can create drawing graphs. So drawing graphs helps to see how a certain results type changes versus one parameter. For example, versus a geometrical position or time. So we have an active stress. So let's right click on the stress and let's go to probe. Here we have 2 options. We can go with add location or on selected entities. So now let's go to our model. Let's choose a few points. Let's click here. Now we have a point here, element, ID, location, and value of the stress. And we see those information here as well, and our results. We can now click here, and here we have a different node. And now we can add as many nodes as we want, like this, and we see our results here. Let's go down. Here we can uncheck and check show node element number. Let's uncheck. And now we don't see the node element number. As well, we can show location and we can hide location. This one, and we can show and hide value if we want. Here we have report options. So we have here plot. Let's click on the plot. And now we have created a plot. So here we have von Mises stress, and here we have node ID. And now we can see at each node what stress do we have. And you can also save this. And with this you can show graphically what is the stress at different nodes. Let's exit. And let's go up. And here we have another option on selected entities. Let's click on this one. And now here we can choose faces, edges, or vertex. So let's go here. Let's choose this face. And let's click update. And now let's go down. and we can create a plot. Now here we have von Mises stress, and here we have element ID. Let's drag this to the right side, and now we can see clearly the number of the element with the stress. Let's go back. So here down you can see the summary. You can see the average value of the stress on this phase. What is the maximum? What is the minimum? And this is how you can create a different graphic plots. Let's exit. And now we're going to show how you can generate report. Generating reports is a very useful way of presenting the entire analysis data. So here we have report. But before we generate report, we can here click include image for report. Let's click here. And here let's choose current view. Let's click OK. And now let's click on the report. Here we can choose what we want to include in our report. We can go with units, material properties, loads, fixtures, and so on. Here we have some header information, designer, company, logo, address, and so on, and the destination where we want to save, and document name. So let's call this report. We can apply this, and let's publish. And now we have created a report. So here we have table of contents. Here we have some information about our solid bodies, volumetric properties, mass, volume, density, weight. Here we have study properties, study name, analysis type, mesh type, and so on. Here we have units that we used, SI, material properties. So we have alloy steel, loads and fixtures. So we have here reaction forces, reaction moments. So we have force 1, pressure, bearing loads. We didn't have connectors. Here we have a mesh information, mesh type, Jacobian element size, tolerance, mesh quality. Here we have total nodes, maximum aspect ratio. Here we have mesh control that we used, mesh quality plots. So we have aspect ratio quality plots. Here we have resultant force and moments. So we have here starter results. So we have a graphs that we created, von Mises stress, displacement, strain, factor of safety. And here we have design insight. As well, deformed shape. And here we have first principle stress. So now we showed how we can present the results in the FEA simulation. So we can plot results, we can list results, we can create drawing graphs, and we can generate report.